Hello students, welcome to Sharav Sir's classes. Today we will be talking about RMO geometry problems. Let's start with this question. A square sheet of paper ABCD is so folded that B falls on the midpoint of CD, which we will call M. We need to prove that the crease will divide BC in the ratio 5:3. So there's a square sheet of paper. This is a square sheet of paper ABCD, and it is so folded that B falls on the midpoint of CD. So the midpoint of CD will be somewhere around here, and B will fall over M, the midpoint of CD, to produce a crease which will look something like this. So this will be the crease formed, and this is the way B is folded over M. So this is a straight line, okay, and this crease will bisect this straight line at a 90 degrees angle. So let's join this point with this point, and we will call this point Q and this as P. So let the length of each side of the square be A and A units, and let us take this as, let CQ equals to X units. So now we have this as X and AB is A, so is AD and CD and BC. So coming to the question, we have two triangles, say triangle MQ, and we will name this as say N. So MQN and triangle QNB. Now in triangle MQN we have QN common. In triangle MQN and triangle QNB. In triangle MQN we have angle MNQ equals to 90 degrees, whereas in triangle QNB we have angle QNB equals to 90 degrees, and DN equals to NB. So triangle MQN is congruent to triangle QNB, and by CPCT, or corresponding parts of congruent triangles, we have MQ equals to QB. So MQ equals to QB by CPCT. Hence, let's say BC is of length A, because we have taken the each side of the square as A, and CQ as X. So BQ equals to A minus X units. So this is A minus X. Subsequently, this will be A minus X also. So what we have now is MQ as A minus X, which is equals to QB. Now referring to the diagram, we have MC as A by 2, since M is the midpoint, so this will be A by 2, and CQ is X. So considering this triangle MCQ, this is C, this is Q, and this is M. This is the triangle we are talking about. So this triangle has a 90 degrees here because it is a part of a square. This side is X, this side is A minus X, and this is A by 2. So by Pythagoras' theorem we have a minus x square equals to a by 2 square plus x square. Hence we have a square plus x square minus 2ax equals to a square by 4 plus x square. So this will give us x equals to 3 by 8 of a, since a cannot be 0, because this will be equals to 2ax, which is equals to 3 by 4 a square. So we will get x equals to 3 by 8a, since from this we have 2ax equals to 3 by 4 a square, and we have a square minus 2ax equals to 3 by 4 a square minus 2ax equals to 0. So a into 3 by 4 a minus 2x equals to 0. So either a equals to 0 or a equals to, or 3 by 4 a equals to 2x, and from this we have x equals to 3 by 8 a. Since a cannot be 0, it's the side of a triangle, right? So it cannot be 0, hence x equals to 3 by 8. So now we have x equals to 3 by 8 a, and we want to prove that the crease will divide BC in the ratio 5 by 3. So we want CQ by QB. So we want the ratio CQ by QB. So this is equals to x by a minus x. Now we have x equals to 3 by 8a. So CQ by QB will be okay. Moving on to the next page, we have CQ by QB equals to x by a minus x, and x we have found out to be 3 by 8a, and this will be then a minus 3 by 8a, which is equals to 3 by 8a by, this is 5 by 8a, and we get 3 by 5. CQ by QB equals to 3 by 5. So QB by CQ will be 5 by 3. Hence BC is divided in ratio 5 by 3, 5:3. So we have successfully proved it. Thank you.